Hi, my name is Robin and you are welcome back to my channel. In this section, I will be teaching you linear inequalities involving modulus. Modulus simply means absolute values. So we'll see how we are going to solve inequalities with absolute values. Let's dive into it.
What do we really understand? Or when we talk about modulus, what do we really mean? Modulus, an absolute value, simply means that you have two vertical lines enclosing a particular variable or a number. If I have a number 2 and I have two vertical lines enclosing it, or I have a variable and I have two vertical lines enclosing it, that is how to represent modulus or absolute value. And what does this really mean? This simply means the numerical value of what we have. So it simply means numerical value. So numerical value. Now, if you're talking about numerical value, it simply means that I'm not interested in either plus or minus, because if I say absolute value of -2, the numerical value of this is 2. I'm just interested in the number. If I say this is +2, I will still write 2 because 2 is the numerical value. That is what it's meant by absolute value or modulus. So, which tells us that if I have modulus of -2, I'm going to have 2. If I have modulus of +2, I'm going to have 2. So what that simply means is that modulus of 2 simply means the distance of -2 from the origin and the distance of +2 from the origin. So that is what it meant by modulus of that. That is why in trigonometry, when they write AB and they put something like this there, this is modulus. It's just telling you the distance between AB or the distance of AB. So here we are going to be explaining modulus in terms of inequalities. So I can tell you now that modulus simply means the numerical value. As you can see here, modulus of -2 is 2, modulus of +2 is 2. So what that tells me is that it's just the distance from the origin 0 to -2 or to +2. Now, let's go into deep explanation of modulus. Now, before we define numerically modulus, I would like to explain something here. If I assume that I have modulus of x, okay, modulus of x is equal to x if x is greater or equal to 0. You can see here because x here is positive, okay, so that is if it is equal or greater than 0, because if you look at the number line, this is 0, this is -1, -2, this is 1, this is 2, 3, and so on. So for the modulus of x to be equal to x, that is if x is greater or equals to 0, that means x value must ranges from here like that upward. So it simply means here modulus x can only be equal to x if the x value is greater or equal to 0. And what this means is that, what it means is if x is 0 or positive values, okay, so we can see 0 here or positive values, so 1, 2, 3, it cannot be negative. But remember that in our other series of inequality, if x is greater or equals to 0, what it simply means is that it means x is not less than 0. That is what it means. If x is greater or equals to 0, it simply means x is not less than 0. So for x to be less than 0, for x to be less than 0, that means the modulus will be minus x if x is less than 0. You see that? So now we can numerically or give a function. We can say modulus x is equal to x if x is greater or equal to 0, or modulus x is equal to minus x if x is less than 0. This is very important that you understand what this means. And what this means is that the modulus of a number is equal to that number if that number is equal to 0 or positive value. But if that number is its negative of itself, that means it's less than 0. So let's see how this works. Now let's take case 1. This case 1 is particularly about this symbol, inequality symbol, okay? Less than or equals to or less than. So let the modulus of p, let's say, is less or equals to 4, okay? Now in this case, remember that the modulus of p is less or equals to 4. What this 4 is telling you is that the distance between the origin is 4. So if I check from here to here, numerical value distance is 4. Distance from here to here, numerically the distance is 4. So what it's telling me is that the modulus of p less or equals to 4 is saying minus 4 less or equals to p, and p less or equals to plus 4. That is what it's telling me, because we already know that modulus simply means distance from the origin. So modulus of p is less or equals to 4. It tells me that the numerical value, which is the distance from the origin, the distance from the origin is 4, so this will be minus 4. The distance from the origin is 4, so this is plus 4. So when you have a modulus p less or equals to 4, it simply means minus 4 less or equals to p, and p less or equals to plus 4. So what I'm trying to say is that if you're asked to solve something like this, 2x minus 3, okay, is less or equals to, let's say, 5. Okay, so in this case, you already know that this is the modulus given, and the modulus of that is less or equals to 5, and the numerical distance from the origin is minus 5 and plus 5, because this is 5 here and this is also 5 here. So this can also be written as minus 5 less or equals to 2x minus 3, and this is less or equals to plus 5. So this also can still be written as this. Now we are going to take questions on this and you see how it works. But remember that we only did for this one here. So it also works for if you have the modulus of that less than 4. It can also be written as this, minus 4 less than p, and p less than plus 4. So you see, it's the same. It's just the inequality sign that is different from this one. So now for this case 1, if I say if modulus P, okay, is less or equals to B, or if modulus P is less than B, okay, here B has to be greater than 0. B has to be greater than 0 for this rule to work. Then we'll have minus B less or equals to P less or equals to plus B. And this one also, then minus B will be less than P and less than plus B. So this is rule case 1. Okay, this is case 1. Now, what this case is saying is that, for an example, if you're asked to solve 2x minus 3 less or equals to 5. Okay, so let's compare this now. You can see my modulus P is same thing as modulus 2x minus 3. Okay, my less or equals to is same thing as less or equals to, and my B is same thing as my 5. And I said for this case 1 to work, B must be greater than 0. And you can see our B here is 5, which is greater than 0. So because it is obeying what we have here, I can rewrite this modulus as minus 5 less or equals to 2x minus 3, then less or equals to plus 5 or 5. You see that now? Okay, if I have something like this, 2x minus 3 less or equals to minus 5, can I use this rule? No. The reason is that for me to be able to use this rule, remember, modulus P is same thing as modulus 2x minus 3. Less or equals to is same thing as less or equals to. B is same thing as minus 5. But this condition says that B must be greater than 0. But here, our B is less than 0. So, it is not equal. It is not equal to minus 5 less or equals to 2x minus 3 less or equals to plus 5. This is wrong. Why? Because our B here is less than 0. Now, the same thing goes for this one here. Okay, so if I have 2x minus 3 less than 5, okay, this is my modulus P. This is modulus 2x minus 3 is the same thing as that. Less is the same thing as less. B is same thing as 5. For me to be able to use this rule, B must be greater than 0. And what is B? B is 5, and 5 is greater than 0. So I can rewrite this as minus 5 less than 2x minus 3 less than plus 5, which is correct. Okay? Now let's take questions now. Now let's take these questions. Solution. The first question says modulus 2x minus 4 is less than 10. Recall that if modulus P is less or equals to, or modulus P is less to B, where B is greater than 0, okay, where B is greater than 0, then we can say minus B less or equals to P less or equals to B. And this one we can say then minus B less or equals to P less or, minus B less than P less than B. Okay, this is case 1. Now let's put it here, case 1. Okay, So now let's see. So this is less, okay, which simply means this rule. And what is our b? Our b is 10, which is greater than 0. So we can use this rule. In a case where you have your b to be less than 0, you cannot use this case or this rule. So here I can rewrite this as minus 10 less than 2x minus 4 less than 10. Okay, now remember that you can decide to take left right first, then you take the second left right. Okay, so what I'm trying to say here is this. Let me make it easier for you. What I'm trying to say here is that if I take the first left right, so that would be minus 10 less than 2x minus 4, right? If I take the second left right, which is this one, that would be 2x minus 4 less than 10. So you have two questions here. So I can say minus 10 plus 4 less than 2x. So this is minus 6 less than 2x. This one is 2x less than 10 plus 4. So this is 2x less than 14. So I divide through by positive 2. So the inequality remains the same. Inequality sign remains the same. I divide 2 by 2. Okay? So this is minus 3 less than x. And this is x less than 14. So in this case here, this is minus 3 less than x and x less than 14. So it simply means if I look at a number line, minus 3 and 14, you've seen this in the previous video in part 2. So if you have not seen part 2, click on the top right hand corner for you to see that video. So what this is saying is that x is greater than minus 3. So x is greater than minus 3. This is open and it goes to the right. Here, x is less than 14. This is also open and it goes to the left. So you can see it's joining together. So it simply means minus 3 is less than x, which is less than 14. So my solution here is that my solution is minus 3 and 14. Now, please pay attention because this goes a long way. This is a bracket sign, okay? Okay, it's bracket. Bracket here simply means that because this is open, that means it's not going to include minus 3 and it's not going to include 14. Then the values of x that satisfies this inequality is between minus 3 and 14. So minus 3 and 14 is not included. That is why it is open here. But in a case where you have something like this, for an example, you have something like this, minus 3 less or equals to x less or equals to 14. If I put this on the number line, as you have seen in part 2, this is going to be closed, which is simply means dotted on this side, and this is going to be dotted and on this side. So this is minus 3 less or equals to x less or equals to 14. So if it is this case, you can see minus 3 and 14 is inclusive. In that case, you will use a square bracket because it is inclusive the number minus 3 and 14, inclusive the number. So you need to pay attention. So if your solution is this, you have to use this square bracket. If your solution is this, you have to use bracket, which is this one here. If your solution is the opposite, don't worry, I will get to that one. But for now, remember this. So in our own case now, our solution is this. Okay, so let's take question B. Now let's take B. Modulus 9y plus 2 less or equals to 1. Now, the modulus P is something as the modulus 9y plus 2 less or equals to is something as less or equals to. B here is something as 1, and 1 is greater than 0. It simply means we can use this rule. So we can rewrite this as minus 1 less or equals to 9y plus 2 less or equals to 1. Okay, I'm going to use the fast method to solve this. I'm not going to separate it. Now, 9y plus 2, let's take plus 2 to left and plus 2 to right. So it simply means if plus 2 is coming to the left, it's minus, and it's coming to the right is also minus. So I have minus 1 minus 2. Okay, this is now 9y, and this is 1 minus 2. Okay, because if you take plus 2 to the other side, it's minus. So plus 2 here is minus 2, plus 2 here is minus 2. Minus 1 minus 2, that is minus 3, less or equals to 9y, less or equals to 1 minus 2, that is minus 1. I'm looking for y, I would divide through by 9. So minus 3 over 9, less or equals to y, less or equals to 1 over 9. So I have minus 1 over 3 less or equals to y less or equals to 1 over 9. This is what I get. Now, let's put this on a number line. Okay? Let's put this on a number line. So here we have minus 1 over 3, and this is minus 1 over 9. If I take my calculator, you can see, let's see the one that is smallest. 1 divided by 3, that is 0.33. 1 divided by 9, that is 0.11. So 0.33 is lesser than 0.11. So y, this is minus 1 over 3 less or equals to y. That means y is greater than minus 1 over 3. So less or equals, so this is shaded and is greater. It goes this way. Y is less or equals to minus 1 over 9. So this is close, shaded, and is less. It goes this way. So this is a closed system. So minus 1 over 3 less or equals to y less or equals to minus 1 over 9. Okay? So the solution here is that I'm going to use a square bracket. Why? Because it is inclusive because it's shaded. So that is minus 1 over 3, then minus 1 over 9. Easy. Now, let's take question C. Modulus 3 minus 2p less or equals to 5. Okay, my b here is 5, which is greater than 0, so I can use this rule. That is minus 5 less or equals to 3 minus 2p and less or equals to 5. Okay, now this is 3. I can take 3 to this side, that is minus 3. So there's minus 5 minus 3 minus 3 less or equals to minus 2p less or equals to 5 minus 3. So this is minus 8 less or equals to minus 2p less or equals to 2. Okay, it's wise now to take this separate so you can understand. So minus 8 less or equals to minus 2p, and I take this one also, that is minus 2p less or equals to 2. Now if I'm looking for p, I divide through by minus 2. Okay, so because you are dividing through by a negative value, what happens? The inequality sign will change. This is less or equals to, so this will be greater or equals to now. This is p. So the same thing here, minus 2 divided through by minus 2. So here the inequality also will change. So what this is telling me is that 4 is greater than p, which simply means p is less or equals to 4. And p is greater than minus 1 here. So which simply means minus 1 is less or equals to p. Okay, so let's put this on the number line to see if it is combined. Minus 1 and this is 4. So minus 1 less or equals to that means it's shaded and is less on this way. Is less on this way. Okay, and this one means p is less or equals to 4 and is shaded. Oh, sorry, there's a mistake here. Let's go back. Okay, so here p is greater or equals to minus 1. P is greater or equals to minus 1. So p is greater or equals to shaded. Greater comes this way. And p is less or equals to 4. Shaded, because it's less or equals to, then it goes this way. So it's a closed system. So in this case, minus 1 is less or equals to p less or equals to 4. So because it is inclusive, because they are both shaded, that is inclusive, you use a square bracket, minus 1, comma 4. Easy. Now you can see that is case 1. And case 1 is strictly for less or equals to. Let's go to case 2. Now, before I take case 2, I'll quickly show you something here. Remember, this is from case 1 because it's less or equals to 4 and 4 is greater than 0. Now, what this one is telling you is that less than 4 or equals to 4, if I go to the origin now, it simply means the numerical value must be 4. That means the distance. So if I put 4 here and I put minus 4 here, the distance from here to the origin is 4, right? That is the numerical value. So the distance is 4, because if you say 0 minus 4, you have 4. Then this one, 4 minus 0, you still have 4. So that is why this one was written as minus 4 less or equals to p less or equals to plus 4 or 4. You can see that now. So it's a closed system. Okay, it's closed. You understand that? Combined, sorry, it's a combined system. That is why you have it like this. Okay, and it's also closed because this is equals to. Now for case 2, case 2 is about greater or equals to or greater than. Remember, case 1 is about less or greater than, and less or equals to or less than. Case 2 is about greater than or equals to or greater than. So let's say modulus p is greater than or equals to b. Okay, so here where b is greater than 0, then we can say p is greater or equals to b, or p is less or equals to minus b. So for this one, let p greater than b, where b is greater than 0, then p is greater than b, or p is less than minus b. Now, this is the rule we are going to apply when you have greater than or equals to or greater than. What you need to understand there is that this is not a combined inequality, because if I look at this here, this is 0, this is minus b, and this is b. Okay, this is saying p is greater or equals to, so it is shaded and is greater, it goes to the right. This is p less or equals to minus b, so this is shaded and is less, it goes to the left. So you can see it is not a combined inequality like this one here. This is combined. Okay, so this is not combined. So for case 2, it is not combined. That is why you see or. For case 1, it is combined. You call it and. So let's take some questions here. Now let's take this question. A modulus 2x minus 3 greater than 7. Once we have greater than 7, okay, greater than 7, so our b is 7, and we have greater, and this is the modulus, and our b, which is 7, is greater than 0, so we can use this rule that you see here. And using that rule simply means we'll say 2x minus 3, okay, is greater than 7, or this is p greater than b, or p less than minus b is or. So 2x minus 3 less than minus 7 based on this rule. So this is 2x greater than 7 plus 3, or 2x less than minus 7 plus 3. So this is 2x greater than 10, or 2x less than minus 4. Divide through by 2. Since you are dividing through by positive number, the inequality sign remains the same. Okay, so here x is greater than 5, or here x is less than minus 2. Okay, now I will explain why I said case 2 is not combined inequality. Let's put this on a number line. So this is minus 2 and this is 5. X is greater than 5. Greater than 5, not shaded, and it goes this way. X is less than minus 2, not shaded, and it goes this way. You can see they go their separate ways, so it is not combined inequality. So now, what is the solution of this? This is telling you that minus 2 to infinity, negative infinity, that is what it means, because it's continuous. So this minus 2, since it's going to the left, so that means it's continuous. And continuous simply means going to negative infinity. Okay? So that means here, because this is not shaded, so I'm using a bracket sign. Right? It's not shaded, I'm using a bracket sign. You already know that. Okay? Then from minus 2, okay, and it goes to negative infinity. So remember that minus 2 is greater than negative infinity, so you have to write your negative infinity first, okay, then minus 2. Okay, that is this. Minus 2 is greater than negative infinity, so you have negative infinity, then comma minus 2. You are putting a bracket, not a square bracket, because it is not shaded. If it is shaded, you use a square bracket. That is for this one. Then you use union. If you don't want to use union, you say or. Then this is not shaded, right? This is 5 and greater than 5. So that is continuous to positive infinity. And positive infinity is greater than 5. So you have to start from 5. Then positive infinity, or you can just write infinity. So this is what you have. So this is the solution. This is the solution. Remember, you can write it as negative infinity minus 2 or 5 infinity. It's still the same thing. Now, before we take the other question, I quickly want you to pay attention. This solution that you see here is called the inequality solution. It is called the inequality solution for this. Now, we now put this solution on a number line to generate interval notation. So this is interval solution now. This one is interval solution, or you can write it like this. This is interval solution. So you can leave your solution in inequality solution, which is this, or you can leave it in interval notation solution. Interval notation solution. If you're asked to leave your solution in interval notation solution and you leave it in this form, that means you are wrong. Okay, now let's go to question B. Let's go to question B. Let's go to question B. Now, for question B, we have 6q modulo 6q plus 10 greater or equals to 3. Greater or equals to is this one here, and my B here is 3. And it says for me to use this rule, B must be greater than 0. Is our B greater than 0? Our B is 3, which is greater than 0, so we can use this rule. So I can say 6q plus 10 greater or equals to 3, or you can say P greater or equals to B, or P less or equals to minus B. So 6q plus 10 less or equals to minus 3, based on this rule here. Okay, so let's solve this one. 6q less or equals to 3 minus 10, or 6q less or equals to minus 3 minus 10. 6q less or equals to minus 7, or 6q less or equals to minus 13. I divide through by 6, which is a positive value, so the inequality sign will not change. So q is greater or equals to minus 7 over 6. Okay, minus 7 over 6. Let's put this one in decimal. 7 divided by 6. So we just know this is minus 1.17. Okay, or q is less or equals to minus 13 over 6. Okay, minus 13 over 6, 13 divided by 6. So this is minus 2.17. Okay. Okay. So now, so our inequality solution, this is our inequality solution. Okay. So since this is our inequality solution, let's see how to get our interval notation solution. We put this on a number line. Okay. So this is minus 13 over 6, because minus 13 over 6 is less than minus 7 over 6. So minus 7 over 6 will be here. Okay. So for minus 13 over 6, q is less or equals to. Less or equals to. Equals to, that means it's shaded. And it's less, it goes that way. So that simply means it's continuous, right? So this is minus infinity. Then q is greater or equals to minus 7. Greater or equals to, shaded, because it's equals to, and it's greater, it goes that way, and it's continuous. That is plus infinity. Now, in terms of notation, you already know that minus infinity is less than minus 13 over 6. And minus infinity is not the one that is inclusive. It is minus 13 over 6 that is inclusive. So minus infinity, I'll open a bracket, minus infinity, then minus 13 over 6. But minus 13 over 6 is the one that is inclusive because it is shaded. So I will use a square bracket because it's inclusive. A square bracket. Okay? Or, for this one, Remember, minus 7 over 6 is less than minus infinity. So, and minus 7 over 6 is inclusive because it's shaded. So I will use a square bracket, minus 7 over 6, then plus infinity. Plus infinity is not what is included. It's not what is shaded here. So this is plus infinity, or just infinity, then normal bracket. So you need to know when to use normal bracket and when to use a square bracket. So this is the interval notation solution. Easy. Now, question C. Modulus 2 minus 6m greater than 10. Greater than is this one here, and my b is 10. And for me to use this formula, b must be greater than 0. And our b is 10, and 10 is greater than 0. So we can use this formula here. So that is 2 minus 6m greater than 10, or 2 minus 6m less than minus 10. So here, this is minus 6m greater than 10 minus 2, or minus 6m less than minus 10 minus 2. Minus 6m greater than 8, or minus 6m less than minus 12. So I'm dividing through by minus 6, which is negative. So the inequality sign has to change. Okay? So this is m. This is greater now, but this will now be less than because I'm dividing by negative number. So this is minus 4 over 3 because 2 here 3, 2 here 4. Or divide by minus 6 here. Okay. So this will be m. This is less. Inequality sign will change to greater because I'm dividing by a negative number. 6 here 1, 6 here 2. So this is what I have. So this is the inequality solution. Okay. If I put it on a number line, let's put it on a number line. So this is 2 and this is minus 4 over 3. Okay. So m is less than. Less than simply means not shaded, and it's less than, it goes to the left, and this is continuous. So this is minus infinity. And this one here is greater than 2, which is not shaded because it's greater than. And here is continuous, which is plus infinity. So the notation of this, the interval notation of this is going to be minus infinity is less than minus 4 over 3. So the minus infinity, yes, comma, then minus 4 over 3. Remember, this is not shaded, so it's not inclusive, so I'll still use the normal bracket. Or, remember, you can use or you can use union. So let me use union here. The next one is infinity is greater than 2. And this 2 is not inclusive because it's not included because it's not shaded. So definitely is a normal bracket. 2, then comma, infinity. So this is the interval notation solution. Easy. So that is everything on case 2. Now, let's take case 3. Now, let's take case 3. In this case 3, we are going to have 2 conditions, okay? Because for case 3, we are dealing with this one or this one. Less or equals to or less than. But why are we going to check or use 2 conditions? Condition 1. Okay, the condition 1 here is that if the modulus p, okay, is less or equals to b, where b is equal to 0, you can see now I'm talking about 0 now. You know, case 1, case 2, b was greater than 0, but now b is equal to 0. So let's see what is going to happen here. Remember, the modulus, that will be modulus P, will be less or equals to 0. So less or equals to 0. Remember, modulus cannot be less than 0. In that case, it's going to be no solution. But let me explain something here. Let's check something like this. X minus 9 is less or equal to 0. For an example, okay? So let's say when x is equal to 0 now, for an example. So put 0 here. 0 minus 9, that is minus 9. The modulus of minus 9 is 9. So a 9 will be, 9 is not less than 0. So the statement 9 minus 0 minus 9 less or equals to 0. In this case, this is minus 9 less or equals to 0. So this is 9 less or equals to 0. This is false. Why? Because 9 is not less than 0 and 9 is not equal to 0. Now let's say when x is equal to minus 9, negative. So minus 9 less or equals to 0. This is minus 18 less or equals to 0. This is 18 less or equals to 0. 18 is not less than 0 and is not equal to 0. This is also false. But let's say when x is equal to 9, here, which will be 9 minus 9 less or equals to 0. Okay? So this will be 0 less or equals to 0. 0 is not equal to 0. Okay? That is false. But 0 is not less than 0. Sorry. 0 is not less than 0. That will be false. But 0 is equal to 0, which is true. So in that case, when you are given a question that has less or equals to, there will be a solution for the equality part of that modulus, but there will be no solution for the less than 0 part of it. So it is a tricky case or condition. So here, I'm going to give you an example just to explain that. So if you're asked to solve something like this now. X minus 9 less or equals to 0. Okay, we have to solve this. So what I would do here is that I will say x is equal to 9. There will be a solution for the equal part of it, but there will be no solution for the less part of it. You already see it here. So I will say x minus 9 is equal to 0, because equals to 0, there will be a solution. X will be equal to 9. So the value of x will be 9 for this modulus to be equal to 0. So the equality part, you will get an answer, but for the less than part, you will not get an answer. So that is this case or this condition. Okay. Now for condition 2, okay, modulus less than b, where b is equal to 0. That means modulus p is less than 0. In this case, we are talking about, for an example, x minus 9 less than 0. If I put when x is 0, 0 here, that is minus 9 modulus, which is 9. 9 is not less than 0. 9 is not less than 0, so that is false. If I put minus 9 minus 9, that is minus 18. The modulus of minus 18 is 18. 18 is not less than 0. That is false. If I put when x is 9, 9 minus 9, 0. Modulus of 0 is 0. 0 is not less than 0. That is false. So in this case, all values of real numbers that you are going to use tells you that this case the solution is no solution. You cannot solve this, so you say no solution. So if you're asked to solve this now, solve the modulus x minus 9 less than 0. The answer to this is no solution. But if you're asked to solve this one here, the answer here will be x is equals to 9 because of the equality part of that question. So you can see the difference between condition 2 and condition 1. Now, let's take case 4. For case 4, it's going to be about this. So definitely we are going to have two conditions also. Condition 1. Let modulus p be greater than b, where b is equal to 0. So modulus p is greater than 0. So let's see what is going to happen. So for an example, let's say we have something like x minus 9 greater than 0. Okay? So when you say when x is equal to 0, that is modulus of minus 9, and that is 9, and 9 is greater than 0. So that will be true. So when x is equal to, let's say, 3 minus 9, okay? 3 minus 9, that is minus 6. Modulus of minus 6, that is 6. 6 is greater than 0. That is true. Let's use negative. Minus 3 minus 9, that is minus 12. Okay? Minus 12 modulus, that is 12. 12 is greater than 0. That is true. So if I use when x is 9, 9 minus 9, that will be 0. It says 0 is greater than 0. That will be false. So it tells you that every other real number is going to work except x is equal to 9. So which simply means that if I were to solve this, I would say the solution is all real numbers. All real numbers in the sense of, all real numbers simply means minus infinity to plus infinity. So I would say the solution of this is going to be all real numbers from minus infinity to infinity except x is equal to 9. Because if x is equal to 9, it will be 0 here, and 0 is not greater than 0 because that is false. So my solution is all real numbers except x is equal to 9. So that is the first condition for case 4. For condition 2, let modulus be greater or equal to 0, where b is equal to 0, that means the modulus is greater or equal to 0. Okay, let's do the same thing here. So let's assume modulus x minus 9 is greater or equal to 0. So when x is 0, if I put 0 here, that will be modulus 9. Modulus minus 9, and modulus minus 9 is 9, which is greater than 0. That is correct. Okay? Now, if I say x is 3, if I put 3 here, 3 minus 9, that is minus 6. Modulus minus 6 is 6, which is still greater than 0. If I put 3 here, that will still be greater than 0. But if I put x as 9, 9 minus 9, that will be 0, and it is equal to 0. It simply means it is true for all real numbers. It is true for all real numbers. So the solution for this will be the value of x is true for all real numbers. That is for condition 2. So the value of x will be true for all real numbers. So in this case here, the solution here will be for all real numbers. And for all real numbers simply means it's going to be between infinity to plus infinity. Okay? But remember here, it is still between infinity to plus infinity, but except the value of x that will make the modulus 0. Because the value of x that will make the modulus 0 will not make this inequality to satisfy what we have. So that is condition 1 and condition 2. Now, case 5. In this case, we are saying let modulus p less than b or less or equal to b, where b is negative, where b is negative. So in this case, I'm saying b is less than 0, b is less than 0. So when you have case like this, let me just give you an example. Let's say x minus 9 is less than 0. X minus 9 is minus 2 because b here is negative. So when x is 0, put 0 here. That is minus 9 modulus. Modulus of minus 9 is 9. And 9 is not less than 2. So that is false. So let's say when x is 9, okay, which is the positive. So 9 minus 9, that is 0. Modulus of 0 is 0. 0 is not less than minus 2. That is false. So when x is minus 3, that is negative. Minus 3 minus 9 minus 12. Modulus of minus 12 is 12. 12 is not less than minus 2. That is false. So every value of x that you will use will make this inequality to be false. So it tells you that when you are dealing with a negative value on the modulus, it is always no solution. So it tells you that if I have something, for an example, like I said here, modulus x minus 9 less than minus 2, this will be no solution because the modulus of a value is always either 0 or positive. So if the modulus is less than 0 or negative, then no solution. So for this case, for case 5, the modulus of a value is negative or less than 0, then no solution. Now, for case 6, let modulus be greater than b or greater or equals to b, where b is negative, where b is negative. Okay, so for an example, let's have something like x minus 9 greater than minus 2. So x is equal to 0. 0 here, that is minus 9 modulus, which is 9. 9 is greater than minus 2, so that is true. let's say x is 9 here. 9 minus 9, that is 0. Modulus of 0 is 0. 0 is greater than minus 2. That is true. X is minus 3. Minus 3 minus 9, that is minus 12. Minus 12 modulus is 12. 12 is greater than minus 2. That is true. It simply means any real number that you are going to use, this statement is going to be true. Okay? Now let's check when it is greater or equals to minus 2. Okay, put 0 here, definitely is going to be greater than minus 2. Right? Put 9 here, definitely is still going to be greater than minus 2. Put 3 here, is still going to be greater than minus 2. But can anything modulus makes it minus 2 equals to minus 2? No, it simply means that generally any real number that you are going to use, it is still going to be greater than minus 2, which is still going to be true. So for this condition, the solution to this case will be all values of real numbers. So I'm going to take questions so you see how you can represent this in terms of solution. Now let's solve these questions. The first one, 12x plus 1 less or equal to minus 9. Remember, when we're taking all these cases, I told you that the modulus of a number cannot be less than 0 or negative. The modulus of a number is always either 0 or positive or greater than 0. So in this case, this is less than 0. So in this case, it is no solution. No solution. And if you say no solution, you can still show why if you want, but it is no solution. I already showed you why when I was taking the cases. Now, for B, 5x plus 6 modulus plus 4 less than 1. Modulus 5x plus 6 less than, I can take plus 4 to that side, so 1 minus 4. So 5x plus 6 less than, this is minus 3. The modulus of 5x plus 6 is less than minus 3. This tells me that this is no solution. Why? Because the modulus of a number is either 0 or positive, which is greater than 0. But in this case, it is less than 0, which is minus 3. So this is no solution. Let's check C. 2x minus 9 greater or equals to minus 8. Okay? This tells me that the modulus of a number is greater than minus 8, which is true because in the cases that I took, I showed you that whenever you have the modulus of a value being greater than negative or greater or equals to negative or greater than negative, which is the last case, the solution is all real numbers. And all real numbers in this case, I can tell you that you can write it like this. All real numbers will be this. So x value, any x value you choose between minus infinity to plus infinity will satisfy this inequality. So this is the solution to that. Then D modulus 2x minus 9 greater than minus 8. This is still also all real numbers. So the solution is all real numbers. So that is this x plus that. Easy. Wow, congratulations to you. You were able to stay to the end of this video. In my next video, hope to see you because I will be taking linear inequalities involving quotients. See you in my next video. Bye for now.